Hey guys, Chris the Ultimate Recycler. Welcome back to the shed, welcome back to the channel. We have a couple of microwaves on the bench here, and this video we're going to basically see if we can save them. Now these two microwaves were donated to the local charity shop and they featured in one of my Monday marathon videos. Disappointingly, I couldn't resell them even though they were donated and they were nice and clean because neither of them worked. Now we could have just scrapped them out because there's a bit of reasonable value in microwaves as far as the scrap goes. With a big heavy transformer, I get the magnets out of the Magnetron. There's a bit of value for me. There's a lot of little sensor switches, but these ones are nice and clean. They have their glass plates. They have everything going for them except they won't heat your food. What's wrong with them? I'm not sure. I've been doing a bit of reading up on microwave repair. I'm trying to teach myself how to fix everything. Let's dive in and have a look and see if we can fix these two. One is an Anko, the bottom one. The top one is a Kambrook. They're probably discontinued models, but they do look nice. They would be easy to sell if they worked. So let's see if we can get that to happen. Let's start with this Anko one and we'll open it up. I've already taken the plate out, but you can see that it's nice and clean inside. It's quite a presentable microwave. At least it wasn't donated in a filthy, dirty condition. However, the charity shop can't do much if it doesn't work. In fact, they wouldn't deal with it anyway because the local charity shop gives everything electrical to me so that I can test it and make sure it's safe. Here's the details of this one. It's a 900 watt, probably, I don't think it says, but it's probably about a 25 litre. And it looks like there's a date code there of 2019. So it's not super old, 2025 currently as I'm doing this video. So we'll take the cover off and we'll have a look at, for a start, what the dangerous parts are, because even if you're scrapping microwaves and you're not really trying to fix them, there are areas that you need to be careful of for your own personal safety. But as far as repair goes or reusing some of the parts, like some people I've seen try to reuse the transformers, very dicey area. We're talking thousands of volts from these transformers. Let's jump in and have a look at where the goodies are. Okay, to get this one apart, we have a screw each end, and I think there's 4 screws on the back. Now, when I powered this one up, it appeared to work. As in the display lit up, the numbers worked, all the buttons worked. The light inside worked, the fan came on, and when we put a glass of water in for a minute, the turntable went round and everything looked perfectly normal, except it was missing that noticeable Magnetron type buzz once the fan and the lights start up. I've missed a screw. So it was doing everything perfectly except producing radio waves to warm up the water. So the fault has to be on the Magnetron side, the high voltage side, because as I said, the fan, the light, the display, everything worked perfectly. Right, there's the cover off it. And we can see in this end here is where all the works are. Normally everything's the same end as the control panel. We have the Magnetron there. We have the big heavy high voltage transformer here. The mains power comes into this little board here, which has a fuse on it. We know that fuse is okay because if that one was blown, nothing would work. So that little board also has a filter, capacitor and a choke and a few other little bits and pieces. So that's mains in, which goes across to the control panel. And then the actual high voltage area is down here. Oh, you have a fan as well. There's also a light for inside and some temperature sensor switches. So there's not a complicated circuit. There are a lot of safety switches on the door latch in behind there so that it won't run when the door's open. But the high voltage system in these is quite simple just down here. There's not a lot of components. You have the big transformer, you have a large capacitor, in the more modern ones you have a high voltage fuse. There's also a diode that goes from the capacitor to the earth of the chassis. And the fault has to be in there somewhere because everything's working except this Magnetron is not producing radio waves. So we can test a few things there. I've learned a few tricks about testing those, but don't dive in without shorting out that capacitor, because even with the mains disconnected, that capacitor will hold a charge, and we're talking multiple thousand volts. The output on this transformer produces a couple of thousand volts, I think, and the diode does a couple of functions. I believe it turns it into DC, but also works as some sort of voltage multiplier, so you can have not far short of 5,000 volts, and that's what the fuse is rated at. And the capacitor can store that for a while afterwards, even though they're supposed to have a bleed resistor in them to bleed the voltage down once they're no longer being used or once the thing's turned off. Don't trust that. It's good practice to assume that there's super high voltage in that capacitor any time that you haven't shorted it out. So that's what we're going to do first. Okay, now time to discharge the capacitor, and that's the first thing you should do, even if you're just scrapping a microwave, if you picked it up the same day or something because you don't know when it was last used. You need to get a known test lead, so one that you're absolutely sure works. So we'll put this just on the continuity tester on my meter, on my new Fluke meter that I've picked up recently. And many thanks to Nathan and his mates at Sydney Tools in Epping, which was just up the road. There we have continuity. Their shop, Sydney Tools, is just on Cooper Street, just up the road from where Christine had her chemotherapy. So that was great. I was enjoying being able to go duck into there a couple of times. Great guys and some great stuff. Right, so we know this lead's okay. We can then connect it to earth or the chassis, and I'm going to use some pliers with very thick handles just to be doubly sure, and just use the end of the lead here to touch both terminals on the capacitor in here. Get under there to get the bottom one, and just make sure there's no sparks. Once we've done that, it's good practice, I think, as well, to actually short one terminal of the capacitor to the other, so you're 100% sure that there's no charge left in that capacitor. That's the only component that's actually going to hold voltage once the thing's unplugged. So now that we're sure that's safe, we can then start poking around here. The high voltage fuse in here just sits in a little clamp. That is most likely blown. If there's something wrong in the high voltage section, that will probably blow. We still have our meter on continuity, so we can check whether we have any continuity through the fuse, and we have nothing. So let's take that one out because that's blown. Okay, you can buy these on eBay. It's rated at 5 kilovolts at 0.8 of an amp, 800 milliamps. So that's blown for a reason though. So what's caused the problem? Well, it could be Magnetron itself is dodgy. It could also be this diode, this high voltage diode, or it could be the capacitor itself. So we need to check a few of these things. If we take the connectors off the bottom of the Magnetron, and we can see if the filament windings in the transformer are okay. They should register as almost a short. Yep, so that's very low resistance. So the coil in the transformer there is okay. Across the terminals of the filament here of the Magnetron should read as a short, and it does. And there should be no reading from either of these terminals to the casing of the Magnetron. And we have a reading. Okay, it's not a direct short, it's enough to make the continuity tester buzz, but that means our Magnetron is shot. And we'll try the other one, same again. Righto, so that was an easy diagnosis. The Magnetron is no good. It has blown the high voltage fuse. We can still check the diode and the capacitor because if they're good, they might be handy in another job. Because basically this, I think, is written off this machine. This Anko one would only sell secondhand for $20 to $30. It's going to cost me more than that for a Magnetron. Plus, I have to get a high voltage fuse, and they're like $10 or something. So this is now written off. We're not going to fix it, but the rest of it might be handy for parts. Will I keep the transformer and everything? I'm not sure. If I put the transformer in the scrap metal, well, I'm probably going to get near $5 for it, even though that probably doesn't have copper windings anymore. It might on one of the sides, but they used to be all solid copper windings. Nowadays they're aluminium windings. I can get the magnets out of the Magnetron, so I'm going to get a bit of value scrapping it, but this one is beyond trying to fix just simply because it's too expensive to replace the Magnetron. Although, because this unit is so neat, clean, and everything else seems okay, I will have to check the diode and the capacitor. I may well get a microwave that's either filthy dirty or got some major cosmetic issues, or it's got a crook transformer or something else, and I may be able to get a second-hand Magnetron. Probably be worth dropping it in here. If there's no cost involved, it would be worth doing because it's pretty easy to swap them over. So do I start saving second-hand microwaves in good condition, hoping to find parts for them? Maybe. Now let's grab a screwdriver and take the diode and the capacitor out. We should be able to disconnect this wire. These little clips have a sort of a spring tab you've got to press, otherwise they won't slide off easily. I have to get some pliers. There we go, that's easy. Now, just while I'm undoing this, a couple of other things about the Magnetron. The test I did, apparently I was reading that fault isn't that common with Magnetrons, but certainly if you get a reading like I did there, it means the Magnetron's no good. More likely you can have problems with them just with their emissions. They're actually essentially like a radio valve, and we've got a little bit of broken plastic there. It's a little clip broken off, and they can degrade over time. And also you can have troubles with, apparently the magnets can crack. So there's a lot of issues with Magnetrons, a lot of which you can't actually check with a multimeter. But the test that I did, the continuity test, is very easy to do, and if that's your problem, it will show up. In this case, it is our problem. I guess if everything else, if it tests okay and your high voltage fuse is okay, and it still doesn't heat, the Magnetron must be faulty. I think it's a process of elimination. If there's a degradation of the emissions inside and it's just not performing, I don't think that would blow the high voltage fuse. So yeah, I guess in that case, when everything else is all right, but it's still not heating, you would have to conclude that the Magnetron's no good in that respect. All right, so that's got the screw out. Let's get the capacitor out and our high voltage diode here. And I've done a bit of research on how to check these. We'll go through that shortly. And the capacitor should be pretty easy to check. We can do the continuity test straight across. There should, of course, be no continuity between the terminals or with the case. I believe they can short, so that would show up. You'd want to make sure they're discharged before you pull them out anyway, but you certainly don't want to stick your meter on there while it's got a lot of voltage. Trying to do a continuity test, you end up blowing your meter up. Easy enough though, if it reads open circuit, which it should, just to basically do a capacitance test on it. This one is supposed to be 1.05 microfarads, so we'll do that check in a minute. But let's talk about how to test these high voltage diodes. Now, a few videos I found on YouTube said to basically just put this in series with a 9-volt battery, and you can see you'll have a voltage drop one way and not the other. It appears to work, but apparently it's not the best way to test them. And I found one guy that seemed to know what he was on about, and he got a 9-volt battery and he put a 2.2k ohm resistor, apparently it's not critical what value it is, onto the negative of the battery, and that just provides a little bit of current limiting, so you're not totally shorting the battery out. It's not really going to affect your voltage, at least when there's no load on it. So if we turn our meter to DC volts and we go across the terminals of the battery, we should have a bit over 9 volts, 9.29. I think you can see that on the screen. And if we go through the resistor, we basically have the same voltage. So that's what he suggested to do. And then what we're going to do is we'll put the red lead from the meter onto the positive of the battery and the black lead from the meter onto the end of the resistor. So we should still have our 9.29 volts. And then to put the diode across the two, firstly with the banded end to the negative. I'll try and hold this all together, and we should get a voltage drop. And we do. It's down to 7.4. Now apparently 7.4 volts is the forward voltage drop of these microwave diodes. And you cannot just check these diodes on your diode tester, because your meter can't deliver 7.4 volts, therefore they'll read open circuit both directions, which would make you think the diode's no good. A normal meter is only going to give you 1.5 or 2 volts, or maybe 3 volts if it's got 2 batteries in it. Not enough to test a microwave high voltage diode. So there's our voltage drop across the diode. Let's do that again. Down to just under 7.4 volts. If we reverse the direction of the diode, it should not allow any voltage through. And you can see our voltage is still exactly the same, 9.28, whether we touch it or not. And apparently that is the best way to test a microwave diode. This one out of this machine is good. It's not blown. So that's good. I'll check our capacitor next. We can stick our insulated handled pliers across the terminals just to make sure there's absolutely no voltage left in there to harm our meter. But we have discharged it, so it should have been perfectly fine. We've got it set to continuity test, and we should have nothing between the terminals. So it's not shorted, and we should have nothing from either terminal to the case. So that's all good. We had a bit of a beep there because it's accepting charge out of the meter. For the meter to do a continuity test, it has to put a bit of power down the leads, and it's charging just a whisker, and that's why we get a bit of a beep. The moment we reverse it, we get a beep the other way, but that's fine. It seems to test okay. We can now actually put it to our capacitance test. And remember, it says it should be 1.05 microfarad. So let's see what it gives us. We have 1.11. So that's pretty close. What was the tolerance? At 3%. So 3% of 1 is 0.03. So it's a little bit out, isn't it? 1.05, 3% would take it to 1.08. It's 1.11. I don't know that that would be enough to cause issues, but I think that capacitor is not the fault with the thing working. As we know, we've already tested the Magnetron. And so I've put the unit back together with a detailed note of what parts it needs and what I tested, and that can stay in there. And I've also put a sticker on the front to say that it needs the Magnetron, and I've written the model number of the Magnetron there, plus a high voltage fuse. And I'll put that in a suitable storage shelf just for now, just in case I turn up some parts. I don't know if I'm going to keep doing this with all of them, and it's only a cheap one anyway, but we'll do it for now. If I change my mind, it's easy just to scrap it out, and at least I know what parts are worth keeping and what are no good. Rightio, let's get this one off the bench, and we'll have a look at the other one, at the Kambrook, and see if we can sort that out. And here we go. Here's the Kambrook one. It's as with the last one, it's spotlessly clean. It pretty much looks like a new one. I would imagine it's a similar age. The other one was, what was it, about 5 years old? Let's see if we have any dates on the back here. Again, it's a 900 watt unit. I don't know the size again, and I can't see a date here. There's probably a date code somewhere, but it doesn't matter. It looks as new. We've just got to see if we can get it to work as new. Okay, this one had one less screw. It had one on this end and 4 at the back, but didn't have one at the other end. Okay, that's got the cover loose. Let's have a look at the works of this one. Okay, it's a different brand Magnetron. I won't peel that off. It's obviously just to cushion it against the casing. We have another high voltage fuse, I think, but it's a different sort. We have I'm not touching any wires yet. We've got to do the same discharge routine as the other one. Mind you, this hasn't been powered up for weeks and weeks that I've owned it, so it should be perfectly fine. There's a high voltage diode in there, the capacitor. A little bit easier access on this one. The control board's quite tiny, actually. Not much of a board there. There's the light, the high temperature sensor switch there, a tiny little board here with a fuse on it. This one actually looks less complicated than the cheaper one. Now this one would have been a lot more expensive, being a Kambrook. I don't know how much more, but maybe about 150. I'm only guessing, and I think it's a discontinued model. But I don't think they put dates on anything in here. Anyway, we'll go through the same procedure. We'll short out the capacitor and we'll do some tests. Okay, we've got no sparks, which I wouldn't expect to have any. And the short across there, that's all good. So there's no power on the capacitor. All right, let's start with checking the Magnetron. They were tight. Okay, we'll check the Magnetron first. We should have continuity across there. And where the other one failed, we should have nothing from there to the case. All right, this one looks better. So that's fine. We should have continuity across these terminals, which go back to the transformer, so the windings are good there. It looks like on basic tests, the Magnetron might be okay. All right, let's get some wires off the capacitor down here. That was tight, and that one doesn't have the little flexible thing on it. It just pressed on very tight. That was better. All right. Now, our fuse is that one, and it goes into the transformer after that. Should be able to unplug. That's got it. All right, so let's see if we have continuity on our fuse. I would expect not, otherwise the thing should have probably worked. No, we don't. So the fuse is, oh, hang on. Get that in there properly. Our fuse is okay. Right, so why didn't this one work? We better check the capacitor and the diode, but the fuse looks like it's all right. Okay, it looks like it's the same capacitor as what we had in the other one. The diode looks very similar as well. So that should just unplug. Right, we'll check the diode in a second. Let's check the capacitor first. No continuity across here. And none to the case. A little bit of a beep when changing polarity, so that looks good. Let's check that out on our actual capacitance reading and see what it gives us. It's 1.05 by the case. 1.1, that's exactly the same as what the other ones gave me. I guess we need to check the diode. If that tests okay, the Magnetron still could have a problem internally, as we've discussed, but there may be something else going on, because also when all the high voltage circuit's okay, it might not be getting power to the transformer at all, which means there might be a crook relay on the circuit board. So that's another problem we can have. But we're going to make sure the high voltage circuit's okay first. Okay, we've set up for our diode test. We should have 9.29, yes. And let's connect this on here. It's a bit hard with the heat shrink on one end there. And see what we have. Yep, 7.3, just under. Forward voltage drop. And if we reverse the diode, should make no difference to our reading here. And it doesn't. Okay, so that's a good diode as well. So, all right, our high voltage circuit appears to be good. I guess we probably should see if we have power, mains power going from the control board to the transformer. Now, I think we can do that. I haven't done that test before. I think we can do it carefully with it switched on. So I've just unplugged the two input wires to the transformer, which should be 240 volts. That will come from the relay on the board via some safety switches. So we could also have a dodgy safety switch on the door, and there's quite a lot of them there. So I think the fault is somewhere back in here rather than the actual main works of the microwave. I've just checked the primary side, and we have almost, we have our buzzer going. We have very low ohms, which is good, so the transformer's okay. The next check, I guess, is to plug the unit in and see if we get 240 volts at these terminals, because when everything is right and it clicks in, it should deliver 240 volts to this side of the transformer to start the microwave section happening, and that's where I think we have a fault. So let's see if we get any voltage on those when we power it up. I'll turn it round to, it'll be AC volts, and we'll plug it in, and hopefully I don't blow up my new meter. Alright, it's registering a few volts, but then of course it won't deliver the full 240 volts to the transformer until the actual machine's in operation. So let's just hit start. And we have 218 volts. So that should be firing up the Magnetron. I mean, it's a bit lower, but I would have thought that would work. How do we stop that? So I just loosely put the cover on only because I feel safer with it. I don't think you need it. But then again, if you're looking right at the Magnetron, even though it's the back of it, I don't want any risk of any radiation coming at me. It should be all directed into here. Now I've just put a jar of water, and it's hot. I just gave it a test and put a jar of water in, and it's not super hot, but I didn't run it for very long. It's certainly got quite warm. You can see the steam on it. So the thing's working now. Right, so that's odd. Now, I'm thinking if it was a door switch that's a bit dicky, because I've opened and closed the door numerous times since I tried it last time, maybe it come good. It could be the relay on the board still that has got a bit of a corroded terminal, and it might work sometimes and not others. So I think it needs a bit more testing, but I think the issue it has is only going to be a switch issue, either one of the safety switches on the door or the relay on the main board, because everything checks out as far as the Magnetron and the capacitor and the diode and the high voltage fuse and all that seems to be good. I think maybe I'll just put this in the workshop for a while and reheat my coffees with it for a bit of a decent test time. And after a week or two, if it's still performing fine, well, I think I'll take it to the shop. If it does play up, I'm probably best just to look at all the switches on the door. I think I can easily check them to see if there's any crook ones. Maybe we might have a look just before we finish up the video. But otherwise, we've tested the high voltage circuit. Everything seems to be good there. So this one is just about ready to sell, I think. I'll just check those switches to make sure it's not going to break down on someone. Okay, I'm going to take the bracket out behind here. We're on the low voltage side. Well, you know, it's when it's plugged in, which it's not at the moment. It's still the 240 volt side, but it's not the high voltage side. I'll take the bracket out here that holds the light globe, and we should get pretty good access to that bracket where all the safety switches are. It's actually really easy to work on this microwave. There's a lot of room. So there's one screw at the top, and I've got the door open, and I think there's one screw at the bottom here somewhere. Now, will this whole bracket just come out? There we go. That's pretty easy to get to. Now I've got some switches to unplug. And these terminals are always so tight. It's such a pain. We really need to unplug them. Okay, well there's a problem. In trying to get those the wires off the terminals, it's broken the clips and the pin. It's gone quite brittle. So that's a bugger. We can't put this back together now without replacing this whole bracket. Alright, so I think this one is now not going to be saleable until I get another housing here that holds the switches. That's the door mechanism. So that's a bugger. I was just trying to give it a bit of a push and it slipped and we broke that clip, that post and that post. And I can't really glue them back because it won't be strong enough to hold, or at least I wouldn't trust it. Mind you, if it doesn't hold the switch won't operate, and when the switch won't operate, the microwave won't work. So it's not a danger. It's just that I need it to not let go for the microwave to be used. Wouldn't be such a problem if these weren't so tight to get off. These ones don't have the little spring clips on them. They're just super tight to get off. Now that switches the top one. They're the same, because some of them are normally open and some of them are normally closed. That's the same as that one, and the other one has the extra terminal on it. Alright, and I've filmed it so I can see where all the wires go. Get these last ones off. Alright, so that's got our switches out. They all feel like they click okay. But whether things are okay inside, I think they do come apart. We can get a bit of levering here. We can actually see what the contacts are like. Oh, that one's pretty clean actually. There's our little contact switch up the top there. I'll just have to do this with each of them and just see if there's any bad pitting on the contacts. That one looks like it's probably okay. Okay, I think I found a problem because that switch and this one were absolutely sparkling clean inside. That's the contact. So it's pretty good. Whereas this one, the contact is quite black and it's been arcing, and the other half of it is actually worse. So that switch, I think, has been introducing a little bit of resistance to the system, and maybe it wasn't connecting all the time. So I think I will put this microwave aside with the other one, and I'll have to find another one of these brackets because I'm not comfortable gluing these. Hopefully, I've had quite a lot of Kambrook microwaves, so I think I'll be able to get another one of those pretty easily. And I do always, when I scrap them, I save all the micro switches, so I'll have no worries finding another micro switch for it. I could probably clean those terminals up. They don't look eaten away. They're just a bit black. They've been sort of arcing, I think. The other ones are spotlessly clean. So I think I'm going to put that down to being the problem, that maybe it hadn't been used for a while and maybe that switch wasn't connecting properly, and that's why it didn't work when I first tested it. And when I just mucking around here and checking all the high voltage stuff, put it back together and it works. So I reckon it probably would have come good. I could have even sprayed it with some deoxit and it would have been fine for years maybe. But seeing so I've got to get this now, thanks to a little bit of carelessness on my behalf, I might as well keep an eye out for another micro switch and the bracket, and we'll put it back together when we find some parts, and it will be a goer. And I think it's well worth doing this one. Being a Kambrook, I should be able to get about $40 or $50 for it. It's nice and clean, and it'll be thoroughly checked over by the time it gets to the shop. So I've put this microwave back together mostly with, again, a handwritten note in the oven, plus a sticker on the front door, and I'm just going to put them into storage for now. So this video ended up neither microwave still working, but I still hold out hope. I've learnt most of my diagnosis and repair techniques on microwaves, especially for and during this video. So I thought I might as well share it with you. It also documents things like I can look back on the footage of this and see exactly where the wires go for the door switches on this Kambrook model. So there we go. I hope to still get them both going. I just need a couple of donor ones to come in, and I think I'll keep good ones, or at least keep parts out of ones that I scrap, given that they're going to be a fairly easy fix. I mean, they're not difficult to work on. As long as you know the safety protocols, microwaves are actually pretty quick to do. Admittedly, you don't get a lot for a second-hand one, but if it's a better brand and it's nice and clean it's well worthwhile. And if I've got a stack of parts and I know what I'm doing with a bit of practice, I think it'll be quite worthwhile, and we'll keep a lot of them out of the, well, out of the scrapyard definitely, hopefully out of landfill, hopefully out of the waste stream. And if I get sick of them down the track, I will just scrap them out. So it's not a total loss. I've learned something. Hopefully you guys have too. Just no return happening at the moment until we get some parts. Thanks for watching. We'll catch you in the next video. Bye for now.